Okay, example 1 on the next one. The horsepower of a motor is found from this formula. It's a funky formula. T is called the torque, and pi, they don't use 3.1 for it. They use 3 1/7, because that's equivalent to 3.14. Okay, and then we have to find the horsepower. These are the given torques, and these are the R per minute. That's called the revolutions per minute that a wheel turns. Torque is a turning effect. It is a tendency of the armature to rotate. Torque is expressed in pound-feet. Using the torque and revolutions per minute of 4 electric motors, A through D, find the horsepower of each. Now, I'm not going to pretend to know a lot about torque. Okay, I'm not a diesel mechanic. Revolutions per minute is how fast the wheel can turn per minute. Okay, there's probably people in the class that know more about torque than I do. But we're going to find the horsepower with the torque and the revolutions per minute. Okay, so this is example 1. Okay, so HP, horsepower, it's the dependent unit. And then we got 2 pi, we need times by 3 1/7. Capital T is torque, so 6 1/3. Revolutions per minute, that's 2,500. Okay. And 33,000 is the denominator. Okay, so I parenthesize the numerator, and the operations are all times. Times. So I just go through that. So 2 times 3 1/7 times 6 1/3 times 2,500. And I get that, then I'm going to divide by 33,000. Okay, so the horsepower is 3. Roughly 3. So you'd fill in 3 there. Okay, example, and then next part, I'll do it again. Horsepower equals, so we got 2, pi is 3 1/7, torque 5 2/3, revolutions per minute is 2,900, and then 33,000. Okay, parentheses, times. Okay, and I get that, then I'm going to divide that by 33 grand. Okay, 3.13. Round to the nearest hundredth on that. I know you're supposed to do the fractions and all that, but I mean, let's be real. Okay, 2 pi 3 1/7. The torque 7.5. Revolutions per minute 3,050. That's all on the fraction. Then you got 33,000. So again, let's figure out the top. It's just times. 2 times 3 1/7 times 7 1/2 times 3,050 divided by 33,000. 4.5. You can write 4.5 there. That's your horsepower. Okay, next one, horsepower. 2 times 3 1/7. Capital T, 4 2/3 times 3,000. And then 33,000. Okay, so we have 2 times 3 1/7 times 4 2/3 times 3,000. 88,000 divided by 33,000. Now, if you wanted to convert that into a fraction, you can go second, PRB equals, and that's 2 2/3. Okay, and that's how that's done. On a job, 3 carpenters each work 4.5 hours. 4 other carpenters work 6.5 hours. 8 others work 7 1/3 hours. How long did the job take? Okay, you don't have a formula, you don't need one. Okay, so 4.5 hours. Well, that was worked by 3 carpenters. So 4.5 times 3 plus and then we got 6 1/5, okay, that was worked by 4 carpenters, 6 1/5 times 4, and then 7 1/3 times 8. Okay, so you do your times first, here, here, and here, okay. So 4 1/2 times 3, okay, 13 1/2. 6 1/5 times 4, 24 4/5, plus 7 1/3 times 8, 58 2/3. I'm going to add. So 13 1/2 plus 24 4/5 plus 58 2/3. Okay. 96 29/30 hours. If you want to find how many minutes that is, you can take your 29/30 times 60, 58 minutes. 96 hours, 58 minutes. You can leave it like that though. Okay, number 3 is kind of a funky little formula. A simple parallel circuit is shown. An environmental systems technician finds the total resistance of the circuit. Find the resistance of the circuit. Okay, so we have the total resistance, that's what RT means, equals 1 divided by, then we have all these ratios here. 1 over R1, so it's going to be 1 over 15, 1 over 20, 1 over 40, 1 over 20. Okay, so you got 1 over R1, so it's 15, plus 1 over R2, that's 20, plus 1 over 40, plus 1 over 20. Okay, so we parenthesize the bottom there, okay, and we just add all those fractions together first. That is not the answer, okay. Over 20. 23 over 120. Okay, then we're going to divide 1 by 23 over 120. It's going to be 120 over 23, but it will put that answer in simplest form as a mixed number. When you divide 1 by a fraction, it flips the fraction. Okay, food for thought. 5 5 23. Okay, the label on that, the total resistance is ohms, okay, OHMS. Okay, number 4. Pulleys and belts are widely used in automotive, commercial, and industrial equipment. An application of a belt drive is an automobile is shown. Okay, and there it is. There it's shown. The length of the belt is found by using this formula. L equals capital D. Capital D is the diameter of the large pulley. Okay, so it crossed. Plus lowercase d, it's the diameter of the small pulley. Times pi, we're using 3 1/7 because anytime you're dealing with circles, pi is going to be involved. Plus 2 times lowercase c. C is the center to center distance of the pulley in inches. So center to center distance is from here to here. Okay, that's the C. Okay, and then you got to determine the belt lengths required for each of the 4 belt drives listed in the table using that formula. Okay, so L equals, okay, diameter of the large pulley, we start off with 6 1/3, plus diameter of the small pulley, 3 3/8, and 2, times pi, 3 1/7, plus 2, times lowercase c, center to center distance of the pulley, that's going to be 6 2/3. Okay, so parentheses, once again, we got to figure that first. The times 3 1/7 off the ratio. Okay, so we figure out that first. So 6 1/3 plus 3 3/8. 9 17/24. Okay, so I have division times, so, or plus actually, my bad, okay? So you're going to do your division first because it comes first. So 9 17/24 divided by 2, 4 41/48. Then you do your multiplication, which is here and here. So 4 41/48 times 3 1/7. 15 43 1/68. And 2 times 6 1/3. 6 2/3. 13 1/3. And you add. Okay, 28 33/56. There you have it. Okay. Again, there is a quick way to do this on your calculator. So capital D. So first off, you need to put that in parentheses, though. Okay. The higher uppercase D plus the lowercase d, the large pulley and the small pulley, we'll put that in parentheses. So I go parentheses 7 2/3 plus 4 1/8. Close parentheses, then divided by 2, times pi, which we're using 3 1/7, plus 2, times lowercase c, which is 10 1/3. Okay, 31 11/56, or 39 11/56. Okay, the length is inches, so the label's inches. Okay, then parentheses, diameter of the large pulley is 3 1/8, plus the diameter of the small pulley is 1 5/8, divided by 2, times pi, 3 1/7, plus 2, and then times the center to center distance, which is 6 1/3. Okay. Okay, 20 11/84 inches. Okay, and then finally, parentheses, capital D is 1 7.5, plus lowercase d 4 1/4. Close it, divided by 2. And then times pi, which we're using 3 1/7 because it's all about fractions, plus 2 times 9 1/8. Okay, 36 5/7 inches. Okay, last problem, but this stupid thing misprinted, so I gotta get my master copy out. Throw that in the garbage. La 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 la. You guys having fun sitting there? Isn't this fun? Okay, here we go. Okay, number 5. A tank shown, there's a tank, is to be fabricated from steel plate. The specifications call for a 3-gauge plate. An engineering aid refers to a metals handbook and finds that 3-gauge steel plate weighs 9.5 pounds per square foot. Okay, that's the weight. The weight of the tank is computed from the following formula. Find the weight of the tank. Again, how they get these formulas, I don't know. Okay, I'm not but they're in the book and all that. You don't really memorize them, they're always given to you. Weight of the tank in pounds. So pi, we're using again 3 1/7. Uppercase D, that's the diameter of the tank in feet. Okay, diameter is all the way across, so that's going to be 3 1/2 times 1/2. Then once again we have the diameter of the tank again, which is 3 1/2. Capital L, length of the tank in feet, that's 11 1/4. Times weight of the tank in pounds per square feet. Okay, well the weight of the tank was given to us. It says it was 9.5 pounds per square foot, so 9.5. Okay, so we calculate the parentheses. 1/2 times 3.5 first. So 1 3/4. So that's 1 3/4, and I add 11 1/4, which is going to be a whole number, which is 13. Okay, so I have times, 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 so it's all times across, okay? So 3 1/7 times 3 1/2 times 13 times 9 1/2. Okay, put 1,358 and a half. And 0.5 is a half. You should know that. If it says 0.5, round it to go a half. Okay, I need labels. Weight of the tank in pounds, so it's pounds.